Okay, so a fun integral here, and to start, this is what we should do. We should let x equal tan theta, then dx is sec squared theta d theta, right? Also, theta is tan inverse of x, right? And so then 0 becomes tan inverse of 0, which is 0, and then 1 becomes tan inverse of 1, which is pi over 4. So the given integral is, to start, 0 to pi over 4, and then the natural log of x is tan theta, so the natural log of tan theta plus 1. Right? Now, if x is tan theta, then x squared plus 1 is secant squared theta, right? Okay, so we have divided by secant squared theta. And then how lucky is it that dx is secant squared theta d theta? Because now we can do this, which is go like that, right? So the integral is the same as 0 to pi over 4 of the natural log of tan theta plus 1 d theta, like that. Yeah? Okay, cool. Now, where to from here? Well, next we need this property, which is that the integral from 0 to a of f of theta d theta is equal to the integral from 0 to a of f of a minus theta d theta. So this is true. So then, if we apply it in the situation where a is pi over 4 and f is the natural log of tan theta plus 1, then what we could do is write that this is 0 to pi over 4, and then the natural log of tan of, instead of theta, pi over 4 minus theta, that's the a minus theta plus 1 inside the argument of ln, right? And then d theta. Okay, cool. All right, now we need to use the tangent angle difference formula. And I have videos on that, so feel free to check them out. But yeah, tan of pi over 4 minus theta is equal to tan pi over 4 minus tan theta divided by, and then it's 1 plus tan pi over 4 tan theta, right? Okay, so that is tan of pi over 4 is 1, so we have 1 minus tan theta divided by, and then it's 1 plus tan theta. This is equal to tan of pi over 4 minus theta. But in the argument of the natural log is not just that, but we also have the plus 1. So let's get rid of this equality, but we could put the plus 1 here and work from that, right? Okay, let's make space here so we can kind of like do this, right? Now, this says with the plus 1, it's equal to 1 minus tan theta, and then plus 1 plus tan theta, all over the common denominator now of 1 plus tan theta, right? Okay. All right, now this happens, right? And so this here is the same as 2 divided by 1 plus tan theta. Okay, so not unlike what I just did over here, let's make space above this part, right? And so yeah, so what's next? Well, this is going to equal 0 to pi over 4, and then the natural log of what did it become? 2 divided by 1 plus tan theta, right? Now, remember, the integral that we're working on, this guy here, after our original substitution, it had become, this integral had become 0 to pi over 4, and then it's become tan of, the natural log of tan of theta plus 1, and then d theta, right? It had become that, right? Now, let's call this here a, right? So again, after our original substitution for x with tan theta, our integral had turned into integral 0 to pi over 4, the natural log of tan theta plus 1 d theta, right? Okay, because it's about to show up again. Where you say? Well, here, this is equal to 0 to pi over 4, using the log rules, the natural log of 2 d theta, and then minus integral 0 to pi over 4, and then it's going to be the natural log of 1 plus tan theta d theta. Yeah? Okay. And it's not 0 to pi, it's 0 to pi over 4, right? Right there? I think I said it right, I just didn't write the over 4. But now I did, so live with it. No, okay. So you know, the reason why I reminded you that this here is so that we can call it a and substitute, right? So where we're at now is that the original integral, this here, which is the same as this here, which we've called a, right? A is equal to, what is this? This is just the natural log of 2 times theta evaluated from 0 to pi over 4, which is the natural log of 2 times pi over 4. So a is equal to ln 2 times pi over 4, and then minus, this here is a, right? This here is a, right? Okay, so minus a. Why is this minus sign so high up? So minus a. Yeah, so you see where this is gonna go? Right? Okay, so we're done, right? Because now we have, if we add a to both sides, we have 2a is equal to pi over 4 times the natural log of 2. Right, that's got a better ring to it. And if I divide by 2, we see that the integral we're seeking to solve is equal to pi divided by 8 times the natural log of 2. Yeah? Okay, cool. Bye.